Hi, Sportster Paul here. We're going to show you my generator test set that I built decades ago. It took all day to figure out how it worked and all the things I did 20, 30 years ago when I built it. It's a DC motor, a DC motor I found at a salvage yard in Silicon Valley. Maybe a horsepower. This big ugly thing, it's got a variable transformer, a variac, to go from 0 volts all the way up to about 140, 150. It actually will go above line voltage. It's got a DC ammeter and a DC voltmeter. DC because that AC coming off of the variac, it's a alternating current wall power kind of thing. It goes into a big diode that I got on a heat sink in there. And then there's what we call garbage can capacitors, because they're as big as a garbage can, they're gigantic. There's 4 or 5 of those, and that takes the ripple out, the AC ripple out, makes a fairly decent, unregulated, kind of Mickey Mouse. I was worried about heat. I put a fan on it, so when I plug it in, you'll hear this little fan going. So, and then here's a box, same thing, salvage yard junk. I took some pictures inside, because I had to get into this thing trying to figure out how it worked and what I did and why some things weren't working right. So it's got a whole bunch of load resistors. It's got this master switch here, right? You can just disconnect all the load. Then each of these switches is 5, maybe 6 or 7 amps, here, here, and here. Then this switch is this rheostat, so you can make an adjustable load. And then this little switch here is this tiny little rheostat here. And for a real fine, I don't even know why I put it there. Never use it. Over on this side, this switch is a brake light, you can see in the back. I wonder if I could power this real quick. This is a power supply. We're going to show how you can turn a generator will work as a motor. So will it reach? Just barely. So we're going to plug this in. Now we've got that. Oh, I got to turn on the main switch. That's the brake light. This middle one, can you see? The middle one powers an ignition coil. And that's why I had to take it apart. What did I do? Well, what I did is this just applies power to the coil. This is the other end of the coil. And then the 2 wires and some kind of Mickey Mouse. Can you see that? You know, big flat washers with spark plugs screwed in. So then if I short this, can you hear it? Hang on. So the theory is I could come out of this plug to, if I spin a distributor, and I can test ignition. So maybe we'll be doing that one day. But with this to spin the motor, here's one of the generators. I organized the generators, all that stuff we had from the overview show. It turns out I have 4 Harley cast iron end bell 65A 12 volt generators. It's cast iron here and cast iron here, and that's how you can tell it's old school. Then here, 1, 2, 3, 4, 5. These are aftermarket, including that Cycle Electric outfit, that really good aftermarket outfit that bought the Prestolite tooling from Prestolite when Harley stopped ordering generators. This chrome one, I think, is a 6 volt. I'm not sure, but we'll have to find a way to prove that out. But these have aluminum end bells. I think one might have cast iron up front. The problem, I wonder if I could find it real quick here. Let's see if we can bring it over to this camera. See that right there? Bust it out. Because this is aluminum, it's already been helicoiled, and now it's broken out again. Now what's nice about these is, you see how a hex is molded in here. That keeps these screws from turning. So like if you put on these goofy brackets that I hate, don't put these chrome covers here. Don't wrap it with chrome because that just overheats the generator. I don't even like putting on a little chrome end piece with this thing because it makes this bearing run hot. Why make stuff run hot? But because it's aftermarket aluminum, these don't turn. In the factory ones, they're just, let's see if I can grab one. I'm going to get my exercise today. The factory ones, they're just a smooth hole, right? And so a regular socket won't fit. I had to get a nut driver. It's the only thing with a thin enough wall. But this, it's staked. There's like little splines on this bolt that pound in and are in theory supposed to keep it from rotating. So it could be mounted up and you could loosen and tighten these nuts. But you know how that always works. I wonder if I can find, here's the setup. Cool. So here's a pair, here's all the parts. What do I got? 1, 2, 3, 4, 5 frames. Set of end bells aluminum, set of end bells, I think cast iron, another set cast iron. So the makings of 3 more, and then all these armatures here. 3 of them I'm going to show you are guaranteed bad. So this is the deal with the early model ones, which you may have to end up taking off the generator. And when you do, remember there's that big flat washer, so you got to kind of angle it and do that goofiness. Right here. Where am I going to put it? This is a little fatter, and it's supposed to have, it's not supposed to be all smooth like this. It's supposed to have stakes, and those stakes go into this hole, you know, they tap it in. Well, they wear out, and then you got a pain in the butt. But you can see how close this clearance is, because this has been relieved for the case. So there's that. Oops, wrong hole. Okay, there we go. Over here, heaven, 7 Hitachi 1982 and later, 82 to 84 early. Man, they're smooth. They sound nice. They do have great. I never fired one up before. Anytime I see one on eBay, anytime I'd go to the Cow Palace swap meet, I would buy them. $60, $80. I see why they're worth collecting, right? I have one on my XR 1000 because that's how it came. But the theory is to get these on my other Sportsters, my 4 other iron Sportsters. So I'm not going to mess. I got a K model generator, 6 volt. You know, that's a whole separate subject. I'll probably do that as part of a K model series where I take apart the K model motor. But these are beautiful. One of the things I hated, the nuts on the, can you see one of them? Here, I guess you see here. It's not 1032. These are 1032. And because this got shipped from California out here to Florida and they clanked together, a lot of these got mashed. Pro tip, leave a couple nuts on the end of this so these don't get mashed up, you know, if you're throwing them around or moving. So I had a cheap Vermont die that you take the starting side, you get down halfway, then flip it over and go from the other side. So that worked out all right. So this is, what is it? I took a piece of, got some masking tape. I'm marking them all to keep them straight over the next months. We'll mess with that. We'll get regulators involved and show you the whole thing and get an oscilloscope and take pictures. That's down the road. Right now, it's just, do any of these work? And it turns out most of them work. 15 volts, 10 amps, best output, number 4. 13 amps, 12 amps. 10 amps, 12 volts. Loose bolt. Oh, that's one of these bolt spins here. This one collapses on load. This is the weirdest thing I've ever seen. Maybe if we have some time at the end of the show, I'll install this one. It'll power up, with no load, right? Because I got a voltmeter here. Boom, up it goes, 14 volts, 13. Then you start putting any load on it, and it just dies completely. The field coil measure is okay. So, not sure about that. Here, this is the one I think is 6 volts, 10 amps. 15 amps, 12 volts, no output. So here's a dead, no output. Here's a dead one. No output. Oh, okay. But it'll motor. In other words, when we use this power supply here, it'll spin it like a motor. So with these dead ones, we'll combine with these parts and hopefully we'll get some more working ones. These are precious. These all, I think, it's stiff, won't motor, but, oh no, this is a dead animal. 15 volts, 10 amps. 10 amps, 15 volts. 10 amps, 10 volts, 15 amps. And all this is rough because I'm having trouble with this coupling that keeps spinning the motor out. So when I get that figured out, next few shows we'll do a more thorough. And we're going to rebuild these, right? We'll have a show where we just show you going through a generator. My website has an article, my 62 sumped, right? Because sat too long, oil comes down. So I started it, and the gear case fills with oil, and it blows out the breather. I had so much oil, it blew the seal out. This seal right here, right? This is the part that mounts to the motor. This seal actually popped out, and just hanging there, it didn't do any damage. So it wasn't too hairy. Just get the generator off, strip it down, tap it all apart, tap the seal back in, back on the road, and don't, hopefully, I bought one of these fancy oil pumps. Oh, what else? Okay, these armatures. I got 3 of them I want to show you that are going to go in the garbage. I don't know how close. Let's see if I can focus this closer. Come on, baby. There. Now that I got it focused, can you see? You can feel, right? This one's all pitted and junky. This one, it'll hang a fingernail. And then same thing on this one. This one isn't too bad. Actually, I think this is a good one. Let's see how good my skills are real time. This is it, I think. You can feel stuff you can't even see. This one. Right? It won't quite hear that, but you can just feel it's a little smaller. And when you put the bearing on there, the little needle bearing that goes here, it rocks a little bit. So these 3 are junk, right? You can't use them for anything. So that's part of the stuff of this whole getting organized. I paid $1 a pound to move them here. So this load thing, it's got resistors for resistive load. It's got a headlamp inside there. It's got a headlamp, tail lamp set up, and then a brake light. It's astonishing. An old 65A Harley generator is rated at 10 amperes output. 10 amps. That's not a lot. At 13, 14 volts, 130, 140 watts, right? A powerful light bulb. That's all you're going to get. These have a higher rating. I'm not sure. I couldn't find it real quick, but we'll do it. We'll learn. But you got to be careful. You can pull 15, 20 amps out of that thing for a little while. But continuous, it burns up the armature, and that's why usually what goes bad is the armature. So here's our test setup. Here's the DC power supply that's going to spin this motor, that's going to spin this generator. This generator goes in like this. I'm using a little rubber hose as a coupler. All this was home-brew stuff that, of course, I wish was better built now. So that goes there. This goes down. Now, when checking them out, you'll see every one of these, well, you might not see, maybe the Skycam will show it, 5.3 ohms, a little squiggly thing, omega ohms. So this is a clamp, right? So it clamps, this thing's clamped, this clamps this. So you can get a voltmeter like this, turn it to ohms. Well, can't quite see it. And you can just, with electronic ignition, you probably don't leave everything connected. Mechanical, because points work even with no power, you probably should disconnect stuff. But here you just measure 5.30. You may or may not be able to read that. 5.29. That tells you the field coil is about the right size. That's why I think this is a 12 volt, this chrome one, or I'm sorry, is a 6 volt because it measures 3. And that's kind of more of a 6 volt resistance. That tells you it's connected, it's working. The way they do it is one side of the field is hooked to the armature, then this other side, you pull it down to ground, you get output from the generator. You get maximum output. And the regulator, of course, adjusts that, how much current you're pulling out of the field, down into ground. All right? So, get this thing set up. First, you got to ground it. So, this, usually what I do is just put a nut here. Really annoys me that these aren't 1032 on the later model on the Hitachi. And a couple nuts here. Let's see, white is the field. Don't hurry, you'll only get further behind. All right. Good, fast, cheap, pick any two. You folks heard that expression? Why is there energy here? Oh, because I'm plugged in. Matter of fact, I wanted to show you that before I hooked the armature up. This power supply is 12 amps. It might be enough. Some of them at motors. In other words, you've got a hook, and what I might be more descriptive if I could find it, but of course it's gone from 12 seconds ago when I had it. But I did have it, a little jumper. I don't want to use a red jumper for ground if I can avoid it. Here it is. This is going to ground anyway, this way, but to make it more descriptive, let's hook it up like this. Ground the field. Connect the ground to the power supply to this. There's some juice there. Let's spin it a little. It might need some help. Right? It needs to be started. But every generator is a motor. You can hear this fan going now. I reminded myself, see, I leave the safety glasses here. With all this stuff spinning, might even be good to have a face shield. Let me get some of my Folgers decaf. It's getting pretty late. Is it dark out? Pretty much. It took a long time to go through all this to make sure this was working right. Let's take a picture here of the front of this thing. So you can kind of see the homebrew, and those things of it taken apart. It was good enough for the job. It's good enough for now. I wish I had one set up, and I've got some of the parts started, so you can leave the gear on, and you can spin the generator with the gear attached. That would be nice. So I've got a rig. Hopefully it'll spin a whole motor, run the points, run the cams. Won't be any pistons in it, but that's a later project, way later, probably next year. So let's hook the field up. This main switch, make sure it's off. You see what I'm doing? Let's make sure it focused right again. And it's recording. Good, good, good. All right, so we're done with our power supply. Let's turn it off just in case. Spinning, because it usually gets loose here. I'm going to really reef it. All right. See this guy cam? Spinning. Because there's no brush cover on this, so it sits flat. These are a lot louder than these Hitachis, because the Hitachis are all buttoned up. I should put a comparison between the two with the brush cover on this to see how much quieter it is. But down here, you can see here, let's get it 5. It's got 5 volts, right? And it's just loping along. Your bike, this thing runs, if I did the gears correct, looking at cam gears, down, down, up. This is 125% of engine speed. So if you're 1,000 RPM, this is doing 1,250, I think. If I counted the gears right. All right. So 10 volts, 12 volts, and the field. Oh, we got the field shorted. No wonder. Okay, tighten it, tighten it. When we pull the field off, it should collapse, right? Speeds up because we're not loading things. It's an unregulated supply, which is why that happened. So we got our 12 volts, but no load. Let's turn. Want to see, there's one of the lights. That's dragging it down to 7 volts, right, with a headlight on. This is why I wire all my old iron Sportsters so that the headlight doesn't stay on all the time, like the law demands. So we can get up a little more. Let's see, we got the lights off. It's up to 15 volts. Let's throw the first load. Okay, that's 5 amps, but it's way down. Throw more power in it. See how fast it has to go to get output? So 7 or 8, 12 volts barely. 14 volts, you can pop this one. We ripped the hose in half. Yes, you get that kind of excitement. But you could see, it was, well, maybe you can't read it, but we were getting our 10 amps out of this thing, but that's 10 amps at a lot of RPM with, a horsepower or two going into it. At idle, you're not going to get 10 amps, right? That's one of the pains. These are supposed to come on better at idle, and that's why people like alternators. Alternators, by their nature, work good at idle. So, I'm trying to unplug this thing so the fan stops. So I'll strip this down. Maybe I'll set it up and see if I can show you. Go away and come back and show you that one that collapses. It's the weirdest thing. So I'll fix this little piece of hose, and these are nice. I don't know if we'll have time for that. So anyway, we'll be back in a flash. All right, we got this problem, this one that collapses under load. I don't understand it. I got this one in here. Didn't tighten it down. How's the Skycam doing? Not bad. So it won't quite motor on its own. Some of these, if you just put, this isn't a powerful supply, it's 12 amps. It's not like putting a car battery. Car battery would probably turn it, right? Because it can put 100 amps. It just turned a little. What I found is I can kind of cheat a little bit by giving it a boost. Come on, Paul. Here we go. See, I've turned this off, so there's no power going to the motor now. Once it starts now, this thing seems to motor okay. I can't quite tell you. Oh God, it's drawn 10 amperes motoring at about 13.5 volts. So it will motor, right? Which is a good sign. Every generator is a motor. Let's take this off. We got our ground coming here. Here's our field. Oh, I should waste your time doing this. White is the field. This is this. I learned about one of the not splines, but the threaded part here got mashed on one of these good generators, really squished. And that took going to the belt sander. Okay, so that's on, this is going. We got sound, we got cameras. Okay, it's dead. Is this user error? Oh, I got load on it. See, with load, it won't start with a load. It's up to 10 volts. You can hear it's going a lot faster just to get to 10 volts. So there's 13 volts. So we'll do this adjustable and no other load, right? It's 11, 12, 13 volts, no amps, maybe a tenth of an amp. Okay, maybe an amp, 2 amps, it's down to 10 volts, 3 amps, and then it collapses. See, now it's back. Okay, what else did I want to show you about this goofy thing? Oh, why it would be not working in your bike. Okay, all load off. Okay, here's 50. Oops, I spun this. Trust me, what I was going to show you is if I turned on the headlight and stuff, this thing would have collapsed. So you couldn't run this generator, but oddly enough, unloaded, it'll make some power. Is the commutator glazed over? The field, when I measure the field coils, 5.3 ohms, the field coils rarely go bad. So I wanted you to see that. This is the brush plate. There's this little pin here. When we rebuild one, there's a notch here that fits. And then this is, I believe, the armature. This is that thing I told you about where they dig in. So this stuff tends to be okay, right? I have had to pull them apart and substitute in new field coils. But this is pretty robust. These don't burn up because a field can have all kinds of voltage across it. 2-3 amps through it, and it just won't burn up. Whereas an armature, usually you don't have a good regulator, or you've got a big battery that's really dead and it's pegging, taking 15-20 amps for many, many minutes, and that burns up the armature, and that's what goes wrong. So we will tear into, maybe this is the one to tear into. I figure start with the factory cast iron end bells and use the cast iron end bells from here, and see if I can try different armatures. I'll do that on my time, and then if I figure out what's going on, I'll show you. So, what else? There were some odds and ends I wanted to talk about. Don't wrap up. Don't use those chrome wraps. It can short out here at the terminals, but it holds heat in. And heat, a hot armature is worse off than a cool armature, or the brushes. That Hitachi I have one Hitachi with the weirdest number. I think this is it, 2998082. All the others have the correct number, 65B. That's the 1982, the parts book. This base number, 29980, it's a spring used, in the 79 parts book. I have to believe this is a very early production and Hitachi made a mistake, or Harley didn't tell Hitachi the right part number, and somehow they put the wrong part number on. Because it's inconceivable this is supposed to be the way it is. All the others say 65B, 29975. So that's a little mystery for later. I guess next time, we'll get regulators. I should mention the outputs I'm getting. The field coils are they can take more current than needed to fully magnetize. Because they design them, they want to saturate. They want to get all the magnetism they can in those steel poles, right? So they wind enough windings and figure all that out. So when you have a regulator hooked up, it's not like you're dead shorting here. It's regulating to an optimum to get the most voltage out of it, and that actually gives you quite a benefit. You get a lot more. That's one of the things for future shows. A generator without a battery has a lot of trouble. I tried and tried, and that's one of the reasons I built this, is to design a voltage regulator that works with no battery for magneto bikes. I think the Bosch mechanical point voltage regulator coils, out of a Volkswagen, that's what Harley used. They seem to do okay, and I think that might be the practical thing, maybe with one of those battery eliminator capacitors. But like I say, I got a broken collarbone from getting hit from behind, so I like batteries in my bikes, not to mention coil ignition instead of magnetos. I've switched over. So next time, we'll probably just tear through one of them, maybe test it afterwards, just to say, hey, did we fix anything? And just show you the procedure to do a generator rebuild. I think I've got enough rebuild. Even if I don't have new rebuild parts, you'll get the principles on how to tear into one of these. All right, Sportster Paul, catch you next time. Bye now.